Okay. I don't know what all that is there, but I don't know what that is. There we go. All right, so today we are learning how to use a shortcut to prove triangles are congruent. And 4 shortcuts, in fact. These are the 4 postulates that will allow us not to have to prove that all 6 parts of a triangle are congruent. So this slide says the definition of congruent triangle states that you need 6 pairs of congruent corresponding parts to prove triangles congruent. But actually, we can prove triangles congruent when particular pairs of corresponding parts are congruent. And that's what we're learning today. So the first one we're going to learn about is what they call side, side, side congruence. So if you're looking at those figures, what do you notice? If you're looking at those 2 triangles, what do you notice, Amaya? Very good. All sides of one triangle are congruent to another one. So we see that here we see that AB is congruent to XZ. We see that CB, the side CB has 2 dashes, and side YZ has 2 dashes, so those are marked congruent. And that means that side BA that has 3 dashes and side BX that has 3 dashes. Now remember the order matters there. If I say side BA, then I have to say side ZX when I'm stating that they're congruent because the corresponding parts have to be in the same order. So what does that mean? Well, that means if you look at angle B is formed by this side that has 2 dashes and this side that has 3 dashes. That is the angle in between there. So the angle in between those 2 sides is the corresponding angle to angle B. Does that make sense, Thomas? Does that make sense? Morgan? So now that we know all 3 sides are congruent, we don't have to prove that all 3 angles are congruent. Now we can say the triangle CAB is congruent to triangle. So remember, name your corresponding parts in the right order. So C is congruent to what angle in the other triangle? Miles? Angle C is congruent to what angle in this triangle? Angle C? What is the corresponding congruent angle in every triangle is Y. Angle A is congruent to angle X, and angle B is congruent to angle B. So if we name this triangle as CAB, then this triangle has to be triangle YXC. That order matters. Any questions? So that's one of our shortcuts. That's a postulate. We will eventually be using that in a proof. But right now, we just have to be able to recognize that these 2 triangles are congruent and state they're congruent by side, side, side. So we use abbreviation for side, side, side congruent. Okay. The next shortcut we can use to prove triangles are congruent, another 3 corresponding parts. 2 sides and an angle. Here, 2 sides and an angle. If we know 2 sides are congruent and 1 angle, well, it does depend on the angle. So here you can see that it says that 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. So the question is, what is an included angle, right? An included angle, let's read the definition and we'll talk about it, is an angle formed by 2 sides lying directly between them. we look at two triangles. I'll let y'all take this first. Okay, so if we have, what is this top triangle? So this triangle, we're looking at angle X. The sides that create angle, I said angle X and I put it down as W. I meant angle W. The sides that create that angle, so two segments meeting at a vertex create that angle. So this side and this side. Together, when those sides meet, they form this angle W, right? So the angle formed by two sides, and it lies directly in between them. So this angle is in between the two sides. Does that make sense? Angle X is not in between these two sides. Angle X could be an included angle, but not for these two sides. Angle X could be an included angle for this side and this side, right? It would not be an included angle for those particular sides in red. How well? So if we're talking about these sides, right? The only angle that is formed by those two sides that's in the middle is angle W. Right? Angle X is formed by this side and this side. Right? So it can be an included angle, but it can't be the included angle for these two sides. So if we're looking at these two triangles down here, we've got an angle marked congruent, right? We've got a side marked congruent, a side marked congruent. A second side. So the question is the angle. So we have two sides, a side and a side, and we have an angle. So is it an included angle? Well, this side and this side that are marked congruent create that angle, right? So that makes angle N the included angle in these two sides. Does that make sense, Daria? Here, angle R is created from these two sides that are marked congruent, okay? So we can say we do have two sides that are congruent. We have an angle that's congruent, and it is the included angle. So we're going to say that side MN is congruent to side PR, segment PR. We're going to say that angle R is congruent, angle N is congruent to angle R. All these things are marked on the triangle. And finally, we're going to say that side NL is congruent to side RQ, or segment NL is congruent to segment RQ. And while we don't have it labeled that these other angles are congruent, and we don't have it labeled where the other sides are congruent, because we know these three particular corresponding parts are congruent, now we can say that the triangles are congruent, and that means that all the parts have to be congruent. Or the definition of congruent triangle says all 6 parts, corresponding parts from one triangle will be congruent to the other triangle. So if we say the triangle is congruent, now we're stating that all the parts are congruent. Okay? So let's triangle LMN. The first triangle is not that big a deal how you name it. You have to make sure when you name the other triangle that you name it with its corresponding parts in the same order. A lot of jumble up there. All right. So angle L, this unmarked angle on the side of 2 dashes. What do you think is the corresponding angle in the other triangle to angle L? What do you think, Helen? Say it again. The Q? Yes, Q is right. So you can see L is at the end of the angle at the end of the side that has that congruent end, right? So Q is at the end, the other angle at the end of this side of this triangle where that congruent R is. So we're going to say triangle Q. So L and Q are congruent. What angle is congruent to angle M in the other triangle? Yeah, P, the other unmarked angle. And that leaves us R. Angle R is congruent to angle N, and we know that, right? So now that we know, so this is our congruent statement. If they give us this diagram and ask us if these triangles are congruent, we say yes, these triangles are congruent by S, 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 or side, side, side congruent. Since all three sides are congruent, and the other triangles are congruent. So that's our first shortcut. Any questions? All right, so now let's see. We have another shortcut, another postulate here called angle side angle congruent. So two angles and a side. So now instead of the angle being included, the side has to be included. So instead of proving all 6 parts of these two triangles are congruent, we just need to prove that two angles and an included side are congruent. So an included side is the side directly between the two angles. It's basically the side that connects the two congruent angles that we have marked, or that we know are congruent. Well, and frankly, in order for it to be included, nothing has to be congruent. So we're always looking for an included angle or an included side in between two congruent angles. Quickly though, we're going to look at angle X and angle Y. So this side that connects those two angles, that is the included side between those two angles. Right? Between angle X and angle Y, this is the only included side. Now, angle X here, we could have an included side between angle X and angle Z, that would be this side, right? But if they ask us what is the included side for these two angles, it's the side that connects those two angles. That make sense, Ron? Does that make sense, Devanshi? Okay. So here, I see an angle that's marked congruent. So we have one angle. We have a side that's marked congruent. And we have two right angles. Are those angles Y and angle L, are they congruent? How do you know they're congruent, Ashley? Okay. Yes, two right angles. The right angles are a measure of what? Right. So they're both 90 degrees, so now we have another angle. The question is this side that's marked congruent in both triangles? Is it the included side between our congruent angles? So is YZ the included side between angle Y and angle Z? Does YZ connect those two congruent angles? It does, right? So that is the congruent side. So does this side LN, does it connect our two congruent angles? It does. So now we know not only do we have two congruent angles and a congruent side, that side is an included side. Now, here we go. So angle Y is congruent to angle L, we said because they're both right angles. Segment YZ is congruent to segment LN, those represent the sides, right? Angle Z is congruent to angle N, those are marked on our diagram. So now, if we see these, we have to recognize, okay, angle, side, angle. Two congruent angles with an included side. So now we know that our triangles are congruent by angle, side, angle congruent. So I'm going to name this one XYZ. I'm going to state that it's congruent to the other triangle. How am I going to name the other triangle? What do you think, Xavier? Yes, MLN. So that unmarked angle down to the right angle. So X is congruent, that's the unmarked angle. Both right angles are Y and L, and then our last angle is. So now that we know that the triangles are congruent, not only do we know that these things are congruent, we know that XY is congruent to ML. We know that XB is congruent to MN. We know angle N is congruent to angle X. Does that make sense to everyone? Okay. Another shortcut. Wait, this one looks very much like this one, right? This one's angle, side, angle. Two angles and a side. This is angle, angle, side. But the difference is here, it's the non-included side. So, what we're saying is, anytime we know two angles and one side are congruent, we know the triangles are congruent. Now, we do have to be able to tell which postulate states that that's true. So you do have to know which one would have the included side and which one would have the non-included side. So if we're looking at these two triangles here, congruent angle, congruent angle. So far, so good? All right. So, does this side that's marked congruent, does it connect to two congruent angles? It does not, right? The two congruent angles are angle P and angle R. The side that's congruent is not included, or it's the non-included angle. Ashton, you raise your brow for that confusing? Okay, so which side would be included, Ashton? You know? Say it again. So what would be the included side for angle P and angle R? Side. Side is a segment, right? Let's go back over here and let's look at it. So we said included side connects the two angles that are congruent, right? So here, angle Y and angle L are congruent, angle Z and angle N are congruent, and we know the sides are congruent. Our side that's included connects the two angles that are congruent, right? So looking here, does this side that's congruent, does it connect our two angles that are congruent? It does not, right? That would be the included side, so this is a non-included side, okay? This would be the included side, this is a non-included side. So both are proof that the triangles are congruent, right? But this one has a non-included side, and that's fine, we just have to know the difference. So we're going to state that based on our diagram, we know angle P is congruent to angle Z. Based on our diagram, we know angle R is congruent to angle T. Based on the diagram, we know angle our side QR is congruent to side ST, or segment QR is congruent to segment ST. And so that's angle, angle, side. The side is not between the two angles. So now we can name the first triangle however we want. Got three angles as the vertices. But now we have to name the other triangle whose corresponding parts are in the same order. So what angle is a corresponding angle to angle P? What do you think, Dallas? What angle is a corresponding angle to angle P in the other triangle? B is the other corresponding angle. So S is Q and S are corresponding angles. So you said S is right. And then R and T are corresponding, so that's exactly right. So triangle PQR is congruent to triangle VST. Remember, this says that PQ is congruent to VS. Segment QR is congruent to ST. But this congruent statement tells you what parts are congruent. Okay? So we should have had 1, 2, oh, so 1 shortcut, 2 shortcuts, 3 shortcuts. The 4 shortcuts that we can prove triangles are congruent without proving all 6 parts are congruent, right? And then the names are descriptive. So learn the names, learn the location of where that angle is. So here, this is called angle side angle. It should remind you that this is the included angle because it's between the angles. This is angle, angle side. Just this little abbreviation should remind you that this is not an included side. It's not between the two angles. Does that make sense, Thomas? So we have some things that kids think are going to prove congruence. So very often we see kids get a reason for congruent triangles and seeing angle, angle, angle. Angle, three angles congruent in a triangle does not make triangles necessarily congruent. They might be, but we can't prove congruence that way. Are you not going to turn it off, buddy? Oh, hold on a second. I'm trying to. There's a message in my madness here. That's not it, though. I did this earlier. Give me a second. All right. Ooh, what happened? All right. Let's try this. All right. So I'm going to make sure that these two triangles are the same size. Okay. So I've got a triangle, and this triangle is the exact same triangle. Does that make sense to everyone? But you can see that they're the same. So these two triangles are congruent. All three angles are congruent, and the side lengths are all congruent. Let me double check this. That's going to be good. So we're going to leave it just that little bit off just so you can see the change, okay? So if they're congruent, all three angles are congruent. Now, I have two triangles that are not congruent. Would you agree? Let's look and see now. Are the angles still the same? Well, that top angle is still congruent, right, Amelia? Look at the bottom left-hand angle. You can see it fits in there almost exactly. They're still congruent. The bottom right-hand angle is still congruent. But are the triangles congruent? No, because the side lengths are the same. So they can have the same angle measures and be congruent, but they can have the same angle measures and not be congruent, right? So we can't use that as proof that two triangles are congruent. They're proportional, they're similar, but they're not congruent, necessarily congruent. David? Yes, remember when you learned about same shape, different size, so they're proportional, right, or similar, yeah. So the other one, shortcut that you try to use is SSA. Miss Reddy made a note and she spelled it the other way. That's why I have the curse word symbols here, right? So here's the deal. You can't touch your teacher. So you're never going to give SSA, or written in the reverse form, as a reason for congruence. Two sides and one congruent non-included angle cannot prove that two triangles are congruent, if that's all you have. If you only know that two sides and a non-included angle are congruent, you can't say those triangles are congruent, okay? So no curse words on your test, right? So this diagram I didn't talk about, but you can see it kind of proves the same point with first here. Like we've got three congruent angles. Notice they only mark two congruent, because we know, how do we know that these third angles are congruent if only two are marked? Remember the concept we learned in Mario? Very good. Third angle theorem says if two are congruent, then the third one has to be, because they have an exact amount of degrees, 180 degrees, right? So we're looking here. This is a non-included angle between this side and this side. This would be the included angle. Right? This would be the included angle. The angle that's created by the two congruent sides, that would be the included angle. But that's not the angle they tell us is congruent. All right? Does that make sense, Miles? Does that make sense, Elizabeth? So you didn't get the Friday lesson, right? So that makes it a little harder for you. All right. So as a recap, the shortcuts that we can use are these postulates. Dallas, you need something? Okay. The postulates are the shortcut that we can use to prove triangles are congruent or side, side, side. Side, angle, side. That angle is in between the two sides. That's the included side. Angle, side, angle. The side is in between the two angles. That's the included side. And even angle, angle, non-included sides. Angle, angle, side. We can use those shortcuts to prove that two triangles are congruent. What we can't use, first word, and AAA. Okay? Does that make sense, Charlie? All right, so let's do some examples. How are we going to use this that we just learned? Looking at the left diagram, so there's two triangles right here and here, created by crossing two lines and closing the ends. All right, we had some diagrams like this in our last chapter. Can we say that this triangle is congruent to this triangle? That's the question. So would that be four shortcuts? We know we can't say all 6 parts are congruent because they only have 2 things marked congruent. So there's an angle that they've marked congruent, right? So the arc, so we know there's one angle marked congruent. There's one side that they've listed, they've marked congruent. Is there anything else in this diagram that we know is congruent? Can we state that any of the other sides are congruent? There's no marks on them, right? That doesn't necessarily mean they're not congruent. In this diagram, it does mean they're not. We don't know if they're congruent or not. How about any of the angles? So, angle G and angle K, they have no arcs, right? How about these two angles? IHG and JHK. What do we know about these two angles? We should know about these two angles. It's a special kind of angle pair. We learned about linear angle, linear pairs. We learned about alternate exterior, alternate interior, inside interior. Amaria says they're vertical, and Amaria's right. They're vertical angles. What do we know about vertical angles? They're congruent. So we've got 2 angles that are congruent and a side. So we have 2 shortcuts. We've got an angle, side, angle, and an angle, angle, side shortcut. So which one? So we're going to say, we already know if there's 2 sides, or 2 angles and 1 side that are congruent, we know the triangles are congruent. Now we're going to determine is the side included or not included with our congruent angle. What do you think? Or not included? Karen? Stick your head up, keep your eyes up, everybody. What do you think, Analia? Is the side, this side that's marked congruent here, is it an included side or a non-included side? Included, it is. So if we look at this side that's congruent, it connects our 2 congruent angles, right? So that this angle and this angle we know are congruent. This angle and this angle we know are congruent. It's connecting those 2 angles that we know are congruent, so that makes it the angle side angle. And now we're going to name our triangle. So triangle IHG. So what angle is congruent to angle I? What do you think? Adine, can you tell me what angle is congruent to angle I? Remember, it's got marks on it. Very good, J. And what angle is congruent to angle H? H, yeah. So if we're listing these separately, we can't just name them both as H. We would name this angle as IHC, and this one as JHK. But to name our triangles, we can. And not only is it once the G is congruent to the K. Angle G is congruent to angle K. Does that make sense, Vivian? Okay. So let's look at this. This is to our triangle. How many sides are congruent? 2. Are there any angles marked congruent? How many, Morgan? The 2 angles congruent? 1 in each triangle. Is that what you meant? Yeah. So 1 angle. So the question is, are both of these, so we only have 2, we really only have 1 option for congruence, right? That's side, angle, side. So in both of these triangles, is the angle included in our side? So let's look here. Side, congruent mark, congruent mark. Is angle W the included angle in this triangle? It is. It's included here. Is angle X included in these 2 sides, congruent sides? Is it? Remember, included angles are created by the sides. So this side and this side, don't they create angle D? So that means angle X is not included. Right? So it's included here, but not here. So we're going to say not necessarily congruent. We're not giving any curse words. We don't give a reason if they're not congruent. We'll only give a reason or justification if they are congruent. Any questions on those? Right. Does that make sense, Charlie? All right. Look at this triangle on the left. What do we know about the parts? What parts do we know are congruent on that triangle? Well, those 2 triangles, right? Because there's 2 triangles here. This one and this one. Does that make sense to everyone? So what parts are congruent here? What can you tell me is congruent here? Harlan, can you give me 1 part that's congruent in both triangles? Sorry. So angle B, there's 2 angles there, right? You're right, though, Harlan. So angle ABC and angle DBA, there's a right angle in both triangles. Those are congruent. There's that 1 angle that's congruent. What else is congruent in these triangles? Maya? Do we know anything else that's congruent? Well, we already said that, right? That's one of our angles. Harlan said these 2 angles. So CBA and CBD are both congruent. So we've already got those marked as congruent. Do you know anything else that's congruent? Is there anything else marked congruent? Sorry? What is D congruent to? Sorry? What does this mark here mean, Maya? Yeah, what angle is it congruent to? It can only mean congruent if you have 2 of them. Yes. So now we have 2 angles that are congruent. Do we know any other parts that are congruent? What do you think, Daria? Do you know any other parts that are congruent? It's kind of a trick one. What do you think, Thomas? So let's look at the sides of this triangle. Here, here, and here. Let's look at the sides of the other triangle. Here, here, and here. What does that say about this one segment? That one one segment is part of both triangles, right? It doesn't have to be, that side has to be congruent in both triangles. So we're going to mark that congruent. If triangles share sides, then that side is congruent. If it was 8 in this triangle, it's got to be 8 inches long in that triangle. Does that make sense? So now we have two angles and a side. We learned two angles on one side. We know the triangles are congruent. But now the question is it angle, angle, side, or angle, side, angle? What do you think? Angle, angle, side, or angle, side, angle? So is the side, does it connect the two angles? What do you think, actually? So these two angles here, if we connect them, is that the side that we know is congruent? And this is the side that's congruent, right? Yeah, so the angles are not connected by that congruent side. That means this is not, so this side is not in between those angles. So here, this says it's got to be in between those angles. So we can prove that these two triangles are congruent by angle, angle, side. And now we're going to name the triangles. We named this one ABC. We're going to name this one DBC. Congruent parts, corresponding parts are in the same order. Also, you see for the vertex for both triangles, they have two vertexes in common, right? B is a vertex in both triangles, and C is a vertex in both triangles. All right, let's look at this last example. Our last one. Okay, great. What do we know about these two triangles? What are the congruent parts they get us here? Aaron, what do we know about this? What are the congruent parts that we know are congruent between those two triangles? What parts are congruent in the left triangle and the right triangle? Say it again. Side MN is congruent to side QR. Yep. Yep. Anything else? Yeah. Side PQ is congruent to side OM, right? Uh-huh. And it's PR. So side PR is congruent to side which one? I lost it. The PR. So PR here. We go from the 1 dash side down to 3. So we're going to go with ON, right? But really what I want you to notice, sorry buddy, that all three sides are congruent, right? We only need those three corresponding parts. What is the shortcut of the postulate so we can say that these triangles are congruent by? SSS, side, side, side. So now we're going to make sure we're naming our triangles in the right order. So angle M is in between the 1 and the 2 dashes, so that's Q. Angle N is in between the 2 and the 3 dashes, so 2 and 3, that's R. Angle O is in between 3 and 1, so 3 and 1, that would be P. Does that make sense? Okay. So tonight's lesson, make sure you have your note, or your assignment, make sure you have your notes out. Remember, no cursing in math homework. Okay? Are you going to scan and submit? And we do have 5 minutes. You can work on your assignment. Yeah. Work on your assignment. All right, scan and submit. Then everybody get your Chromebook out and go to Alex. And it's /. 2, 4-3A.